Let's go for number 27 in this video. Find a domain in interval notation. So another domain problems. Okay. So first, R of x, which is x squared minus 3x minus 28. Hey, it's a quadratic function. This is a quadratic function. What does that mean? The domain is all real. I didn't have to write this down. The domain of any quadratic function is from negative infinity to positive infinity, so that's good. All right, how about s of x? This is going to be a little more challenging. S of x is a rational function. We have x squared minus 3x minus 28 on the numerator. But what we really care about is that denominator. I want you to note that denominator cannot be equal to 0. The bottom of the fraction can't be equal to 0 because we can't divide by 0 in math. So what do we do here? We're going to set the denominator, which is x plus 2. Say that can't be equal to 0, and we solve for x. Subtract 2 from both sides. You will get x can't be equal to negative 2. So if I graph a number line, I will have a hole at negative 2, an open circle at negative 2. But it can go everything to the left of negative 2. Oh, that's too big. And everything to the right of negative 2. So if I write that in interval notation, that will be negative infinity to negative 2, union negative 2 to positive infinity. So that will be the domain of the first one, or the second function. So I'll do the union symbol in the middle and do negative infinity to negative 2. And on this part, the part that comes after the union symbol, I'll have negative 2 to positive infinity. So if you have one excluded value, that means your number line will be cut in two pieces. You cut it right here, so that you have one piece to the left and one piece to the right. I have a feeling the last function we're going to have two holes, two excluded values. So let's take a look. T of x is x plus 2 on the numerator. The denominator is x squared minus 3x minus 28. We know that the denominator cannot be equal to 0. So what I will do is I'll set up x squared minus 3x minus 28 can't be equal to 0, and we'll solve this by factoring. What times what gives you 28? 4 times 7 gives you 28, and 4 has to be positive, and 7 has to be negative in order for me to make negative 3 in the middle. Now what does that mean? That means x can't be equal to negative 4, and x can't be equal to 7. So I have two excluded values for this function. So if I graph a number line, I'll have the smaller number negative 4 on the left, bigger number 7 on the right. Mark them with open circles because they can't be those values. After that, I will go to the left of negative 4, to the right of 7, also the one in the middle. So I have 3 intervals to write as a domain. So the first interval is the one that starts from all the way to the left but stops at negative 4, union the one in the middle of negative 4 and 7, union, and the last one that starts at 7 but keeps on going to positive infinity. So that will be the domain of the last function, and I will need to type that here very carefully. First, I open the union symbol, and let me do negative infinity to negative 4. Let me bring this down a little bit so that we can type. Next one is another union symbol, negative 4 to 7. And be careful when you guys are typing these, because I don't want you to miss this on the test because of a typo. And then you have your 7 and a positive infinity. After checking your answer, you go on to the next problem, okay? But here is me wanting to see if we got this right together. So I submitted it. You won't be able to do this on the actual test, but on the practice test, absolutely, you can do this. You can submit it as many times as you want, and you see the check mark next to that number 27, that means we got that right.